So now I'm going to explain to you how the solution for the infinite resistor problem works. If you worked it out, you would have found that the resistance should be this golden ratio, 1 plus the square root of 5 divided by 2. And if I work that out in decimals, it's 1.61803. Because of the resistors we're working with, that's going to come out to a reading on the meter that is 16.18 if it was perfect. What I have set up for you here is a resistor network, and you can see this resistor is not attached. I'm going to show you how many resistors I need to put in before I get something that starts to look like this infinite resistor network result. I want to also comment that for these resistors, we have to actually work with very special resistors that have very low tolerance because they really need to be about the same resistance in order to be able to get the correct result for the infinite resistor limit. So what we started out here with, we have two resistors. One is here, which is a little bit harder to see, and then there's one here. And what I'm going to do now is I'm going to add a second resistor. And as I add that second resistor, I'm going to change the scale so we can get a slightly more accurate result. And it's now gone to 16.69. I'm going to now add a third resistor in the chain. And when I add the third resistor, we're already down to 16.28. I'm going to just add the fourth and fifth now at the same time. And you can see now, this is now with 5 of the resistors in the network. We're already at 16.21. And so it really doesn't take very many in order to get to the level that is actually the result of the infinite resistor network. And given the fact that the tolerance on each of these resistors is only about 0.2%, that result is really about as accurate as we would expect to get even if we had an infinite resistor chain.